Number 11, a sequential set of data is shown below. Which graph represents this data? So remember that this number comes first, this number comes second, this number comes third, this number comes fourth. And whenever we do the notation for placement, we say A sub 1, A sub 2, A sub 3, and A sub 4. These are your X numbers that tell you the place that they are in line, and your Y values tell you your values. So we are not going to have lines because these are just dots. And you can type these in as a table on Desmos, and your table is just going to match for you. I'm not going to type this one in because I know how to graph these. I think it would be more trouble, but you can type them in if you would like. And again, you're using these numbers like that in your table. So going over 1, up 30.5. Going over 1, up 30.5. This one is not correct. This is the one that we're looking for. Just to double check, let's do another one. 2 and 34. Going over 3 and up 37.5. So answer choice F is going to be correct. Number 12. Monell's lab group is collecting data on the bouncing of a ball dropped from initial height of 17 feet. A table of collected data is shown below. Use technology to determine the exponential function that best models data and predict on what bounce the ball will reach. Height of approximately 1 foot. So what we're going to do is we're going to type in our table. So you go on your Desmos and add a table. I'm going to add a table. And we're going to type in these numbers. We have 0, 1, 2, 3. And then we're going to type in 17, 11.3, 7.2, 5.4. Okay. And now I'm zoomed way out, so my window is showing 5,000. That's why these just look like a straight line. So I'm going to get more normal window. And so there we can see that, and we can see that it's starting to come down this way. So it said exponential. So what we want to do is we want to put a line through here so that we can predict where these dots are going to go. So whenever we want to ask Desmos to do a line for us, we're going to do Y1 worm. And the exponential equation is AB to the X power. And it's not giving me a line yet because I haven't put the subscript of 1 because our table is talking about X1 and Y1. So whenever we ask it, we need to say Y1 and X1. All right, so this gives us our line. And we want the ball to reach a height of approximately 1 foot. Height is over here in this Y column. So if I want a 1 over here in the Y column, I can say Y equals 1. And I can type that in on my Desmos. Y equals 1. Oh, that's not an equal sign. Equals 1. And then I can find where they cross. Tap on it. And so when do they cross there? We have 6.935. And it looks like we have the function and the answer. So we have a couple different things that we can look at for this one. This is giving us an equation. So we're looking at our A and our B value. 16.86 is pretty close to 17.665. I know what that is close to as a fraction. Let's see if it's this one. Some of you are going to know this without typing it in because it keeps coming up a lot. It's going to be close to 2/3, so that matches also. This one is not going to be correct. That's not the formula we used. This one is correct. That's the same as choice A. And again, this is not the formula that we used. It says exponential. This one's linear. And this one is quadratic. since we have answer choices, you could actually type these in and see if they match those points. You don't have to do Y1 worm on this one. Okay, and then the answer is, when will it reach that? And again, our answer was 6.9, and what are we talking about? Bounces. So this says 11th bounce, and we're looking for 6.9. 6.9, we don't have 6.9 bounces. The closest would be on the 7th bounce. So answer choice C is correct.